Now let's discuss the different ways to protect the computer ports. I researched and found these many ways are there to protect a port. Okay, why we are going to know these things is really important because you can't exploit a system without knowing how the system is being working, right? So these things are important. Yeah, number one is closed ports. If any ports are closed, then we can't get into the system, right? If the door is closed, we can't get into that building, right? So that is impossible. Then firewall rules. Some systems are protected using firewall. I mean, few ports are protected using firewall rules. Firewalls are like IP tables, UFW, uncomplicated firewall in Linux systems. All right. So then the systems which are protected using the firewalls, it's highly impossible to get into those ports. Then non-standard ports. Sometimes system administrators intentionally changes the default ports to other non-standard ports so that the attacker wouldn't recognize that. Okay, so administrator don't want to take the chances by keeping the ports in default ports. I mean, running the services in default ports. All right. Next one is rate limiting. It is like suppose if you run any scanning tool like nmap, that will send so many requests per second, right? So by limiting the rate, what it does, if any request from a user or an IP address is coming, then it checks whether that is coming under the rate limit or not. If it not, then it simply blocks that IP address. Well, next, IP whitelisting. What is IP whitelisting? It is like only allowing particular IP addresses into the system by using firewalls. Okay, firewalls or any kind of thing before entering into this service. It checks whether the IP address is whitelisted or not, is allowed or not. Geo blocking means it's like blocking the entire country. Okay, the addresses from the entire country, so it won't allow the any blocked country addresses into the server. Next one is reverse proxy. What is reverse proxy? Reverse proxy like nginx, apache, we can use them. Actually what they do is they simply stand before the server. All right, they take the request and based on the rules which are mentioned in them, they will allow. Okay, they will serve the data. Next one, address network address translation. Next one is a TCP wrappers. TCP wrappers is similar to IP whitelisting because it is also same like that. Why means it also allows the only specified IP addresses. Okay, but TCP wrappers works at service level, like at a system level in server side, while IP whitelisting is implemented using firewalls. Okay, firewall is before the server. Here TCP wrappers is implemented in the system itself, but IP whitelisting is implemented in the firewall. Okay, yeah. And next we have Tor bits. It's really interesting. Yeah, Tor bits is a different kind of thing because it don't reject the attacker's mm, packets. Instead, what it does is it makes him wait for so long, for hours or even days. But how? How does it do? How does it works? Like it reduces the window size of TCP at the server side, so that the data really goes to attackers very slow rate, which will make him to wait for so long. Okay, and there are a few types are there. I mentioned here two types. Endl SSH, it works in application layer for SSH, and Labria. I don't know whether I'm pronouncing those two names correctly or not. Okay. Yeah, Labria is implemented at network layer. Then port knocking. Now let's learn how port knockers are used to secure the ports. Okay. Before jump into the main topic, let me explain you how theory works, how theoretically it works. Let's assume that there is a security guard before the apartment where you should enter into that apartment. To enter into that apartment, you must and should say a few secret codes so that the security would recognize you and allows you. Okay. The same thing happens here. Server is the building apartment and firewall is the security guard. So as a client, you enter into that server, you have to say few port numbers so that firewall will recognize you as genuine and it will allows you into that server and make you to connect to that port which is open in that server. Otherwise you will get unfiltered port when you scan that port or when you reach that port. Okay. And this thing is actually being done by established by the daemon knock daemon. Okay, that will works on background and recognizes the log firewall logs and make the firewall to allow that client to connect to the opened port when the client gives the correct port numbers to that firewall. Okay, now let's see how it works with a practical example. Internal. So I have here two virtual machines. The black one is, let's say, client, and the red one, the spider red one is server. And I have already configured the server. Let me show that to you. So yeah, I configured here to the port 9000. To connect to the port, we have to send this sequence, and to close the port, we have to send this sequence data packets to this sequence. All right, and the timeout between the each request is 5 seconds. After the successful pattern knocking, this command will execute here. Okay, and for close, this will be going to execute. And yeah, now let's before that let me open connection. Let me run the port, and this is the IP address of the server. So I'm opening the port on server, and on the port is 9000. Before knocking, let's try to connect. So I'm trying to connect to the port 9000. You can see that the port is filtered. That means the firewall is not responding to that port. Okay, the firewall just drops the packet which we are sending from the server client to the server. All right, now let's knock that. Knock dot 85. My bad. Yeah, what are the sequence? What is the sequence? We already seen that. Let me show you. To open the connection, we have to send the data packets to these port numbers. Four ones first, and then four twos, and then four threes. So now let's hit. Let me add the flag verbose. So see the packets sent to these three ports. Now let's try the nmap scanning. Oh, it's still showing a filter. See, I have given the wrong IP address. It's 85. Now let's try to connect. So I knocked here the wrong IP address to the wrong server. I now rectified it. See, it's open now. So this is how the port knocking is work. Okay, and to exploit this, we have to try a brute force method that is really impossible, but possible. We have to do so many things, like so many tries for that. Yeah, that's it. And to close that port, we have to knock again with the knocking CM in a closing sequence. That is, we have to knock these ports to close the connection. Let's try that. Four fours, four fives, four six. Now let's try to connect. Now let's try to scan that port. See, now it got a filter. That means the port is closed, right? So this is how we use port knocking. To it's a kind of additional layer for the port securities in computers. Okay, it is a packet authorization, single packet authorization (SPA). See, SPA is more advanced than port knocking because port knocking we saw that it uses few ports, but single packet authorization uses a single port. In the genuine user or genuine client sends a packet to the specified port, okay, and in that data packet it contains encryption key which is only provided to the clients. So they send the encryption key along with that. I mean, inside that packet, the firewall recognizes that encrypted key and allows that specified IP address for a particular time to the original port. After that, the port will be closed. Okay. Then VPN only access. To access any server for this kind of method, you should connect to the VPN. Okay, like what kind of VPN? The VPN which is applied by the administrator or the service admins, like OpenVPN. Few other VPNs are there. Whatever the administrator is specified or configured, those using that VPN, the client should connect to that VPN, and then he can access the ports, that network, that server. Otherwise, the server will be unavailable to the public. So hacker can't, or the malicious actor can't recognize the server. All right. Then we have zero trust or mic. Sorry. Then we have zero trust and micro segmentation. Zero trust means whether you are attacker or real user, genuine one, it don't care. It simply every time make you authenticated. All right. And micro segmentation is like, suppose if there is a server and an attacker somehow get into that server, and first of all that server is divided into so many segments. If the attacker get into one segment, then he needs to authenticate, or he needs to again do some kind of malicious things to get into another segment. Okay. Next one is hardware level port clocking. Since it is implemented at a hardware level, you can't even know whether the port is uh, really open or not, because when port securing methods are implemented by using software level, you at least get to know that whether they are something is there or not behind the firewall, or okay. But in this hardware level, you don't even get a clue whether the port is open or not. Suppose in a hardware level, I mean in software level, you either get a port is filtered or closed like that, but in hardware level it just drops the packet at hardware itself. It don't even passes that message through the OS operating system of the server too, so that you don't get any kind of information regarding that port or network. Next three things are like more interesting. Honeypots. Honeypots are deliberately kept ports for attackers by the administrators. to catch them and to recognize the attacker's behavior. And before he attacks the main ports, the administrators would blocklist the attacker's IP address. Next one is the deception networks. Deception networks is like creating fake servers. Okay, so that if an attacker got access to those fake servers, administrators would be monitoring you, and they keep the things like fake credentials deliberately for the attackers. Okay, kind of a honeypot. Next one is traffic obfuscation or fake banners. It's like instead of giving the original banners when we scan any port, it gives the fake banner like this Microsoft something, instead of giving open SSH like this. So when an attacker wants to find out the vulnerabilities regarding that fake banner, he would end up with doing wrong things, right? So all right, now these are the things. Okay, different ways to protect the computer ports. If you want any, if you want anyone particularly explain more, let me know in the comment section. I would love to explain the things in more for you. Okay, for now, see you soon.